This is for 8.10 today for law of cosines. We last did law of sines though, so we're going to start this warm up out trying to use law of sines just to practice real quick, and then today we're going to work on law of cosines, which is just another way of finding missing sides or angles in a triangle that doesn't have to be a right triangle. It can be used on right triangles, but that's just way more work than we need to because we have other methods for right triangles. So this first question says you are given the following measurements for angles. There'll be capital letters. The lowercase letters represent the side length. You can see also by the units. So 75 degrees is angle B up here. And then we have the length of side C is 9 and the length of side A is 10. So we have those measurements given to us, but we don't know missing side B. That's the only side missing here. And then we also don't know the other angles. And so it says here, you're given that information and we're being asked to find B. Okay, we're being asked to find this side right here. And it tells us right off the bat, why do you think you're not able to use law of sines to do it? Well, because yesterday or on Friday when we were working on law of sines, you can only use law of sines if you have an angle and a side across from it. So the only angle I know is 75 degrees. And so the side across from it has to be B, and I don't know what that is. So I'd have way too many unknowns to be able to try to do sine of B. If you aren't sure, let's go ahead and test it out, right? So if you tried doing sine of 75 degrees over, remember you always divide it by the opposite side, which we don't know what it is, it's B. And then you have to find another relationship between an angle and a side with, again, sine of, you could pick, do I want to pick angle A, do I want to pick angle C? Either way you do it, you don't know either of those angles. So if I did A, I would have to divide it by 10. Or if I had done C, I would have divided by 9. Either way I do it, I just have two unknowns here. I have a B and a missing A. You can't have two unknowns in a problem. You can only have one, right? So we would just say there's not enough information. Given, we would either need angle A or C. As long as you have either angle A or angle C, then sure, you could find that missing side B because we'd at least have only one unknown then and not the other, not two of them. Okay, now we will learn this other method that will be helpful, that we could do a problem like this, because right now if you were given this triangle and all it said was find B, you just wouldn't be able to do it. But as of later today, when we learn about this law of cosines, we can come back and do this one using law of cosines because it will work with this thing called law of cosines, but it doesn't work with law of sines. So the reason why there are two is kind of the different scenarios that we're going to see and how one might be helpful sometimes for those triangles that we had information on Friday where it was like an angle and a side opposite, we had that. Or on these scenarios we're about to see what happens when you have like an angle and two sides surrounding it. So kind of imagine like an SAS scenario here. That's what we're about to see with law of cosines. So I'm going to go ahead and just tell you what the law of cosines is rather than showing you like a proof for it. If you are interested in the proof for it, the answer key on Canvas does kind of explain it in a little more detail. But they're just like we had three fractions yesterday or on Friday with the different sign relationship, like how these were. There was this one, and then there was one for the third angle as well, sine of C, right? Now, for law of cosines, you're going to have cosines involved. And so notice on the diagram, again, the lowercase letters are your sides, and the uppercase letters are, your capital letters are your angles. And so this starts off with, I'm going to just start with the first one, which is going to start with A squared. The lowercase a is being squared, and it's going to equal the other two sides added together and squared. So B squared plus C squared. It almost makes it seem like it's like sort of like Pythagorean theorem, but we're not going to kind of think of it that way. Now there's more to this, and there's a minus sign, then the number 2, and then those same letters B and C here, they get multiplied next. So B times C, and then finally it has the word cosine. And then remember, right after the word cosine, we always need an angle. So the angle we're going to have is going to be a capital A because it has to match with the lowercase a that we started off with. So this is one of the equations that will be given to you. You do not need to memorize this. They will all be given to you right on the test coming up later this week. You won't have to memorize it. You just have to know how to use it. So we'll keep practicing it this week. So here's another one. All it does now for the next two equations is it kind of says, it writes them in different ways because sometimes we're going to want to solve for A, sometimes for B, and sometimes for C. It just depends on what the givens are when we start the problem. But all it does is just kind of change around the numbers, the letters. So with B squared equals, it would then be A squared plus B squared. I'm sorry, not B, C squared, because you can't use the same letter twice. So if this is B, these are the other two, A and C, minus 2 times AC. And they're all just being multiplied together here, 2AC cosine and then a capital B. Because remember, capital B means the angle for B. Okay, so finally, this last scenario is with C being squared. The lowercase c is the side right here, C. So this would be A squared plus B squared minus 2AB. So again, they're using the same letters as always, what's on the side, same side of the equal sign. And then cosine of capital C. Okay, so again, you do not have to memorize these, but these are all of the law of cosines. And again, we only use one equation at a time depending on what variable we're solving for. Now, sometimes you're going to be solving for a side length. That means your variable will be one of these three. Like either you won't know, your unknown would be an A, the lowercase b, or the lowercase c. But everything else should have a number then. Everything on the right-hand side then should have a number. Or the other option is you know all three side lengths, but you don't know one of the angles. And so then you would use whichever of these three where your angle is actually the unknown. Those are the two different scenarios. So we'll try to do one of each kind. The first one I'm going to start with is actually the easier of the two, I think, is usually to find the missing side length versus the missing angle. So to do that, I'm going to actually go back up to this missing, the question above where we couldn't finish the problem because it was not in the correct form. Like it couldn't be used for law of sines, but I could use law of cosines on it. Okay, so starting with, I want to keep it so that you can still see the law of cosines here, but that you can also see this triangle because that's what we're going to use to help. And I'm just going to write it right on the side here because although we couldn't do law of sines, let's try out this law of cosines now to do it using law of cosines. So remember, we're looking for lowercase b. So if I look at my letters here for my law of cosines, I'm going to use the second equation that deals with lowercase b, b squared. So we're going to write b squared equals, okay, and then anywhere you see the letters A and C, we're going to grab those numbers from our triangle, right? A is 10 and C is 9. They told us that right from the beginning. So A was 10, so it's going to say 10 squared plus. Then we have C squared, which is 9 squared. So you're plugging in both those numbers. Then there's a minus sign and a 2. And then A and C, remember we still know what those are. A is 10, C is 9, so we're plugging those in. 10 times 9. I like putting them in their own parentheses like this, or you can put the little multiplication dots if you'd rather do it that way. Okay, and then finally we're almost there. The last part just says cosine capital B. So cosine, and the capital B here is that 75 degrees. Okay, so this is going to be at 75 degrees in parentheses. Now, if you look at your equation, we don't know what b squared is, we don't know what b is, but every single thing on the right-hand side is all filled in, like has a number. So all you have to do is literally grab a calculator, start typing everything in just like you see it. Start from the 10 squared all the way down. Just make sure you're in degree mode still because we're still working with cosine, which is in degrees, right? So I'm typing in 10 squared plus 9 squared minus 2 times 10 times 9. And right after that, you don't even have to put a multiplication symbol unless you want to. You can write cosine. And then remember, we have to put an angle with it. So 75 degrees is the angle. And as soon as you do that and you hit enter, it's going to give you an answer. So we're going to write down a few numbers here. Don't round too early. So I'm going to write 134.4126, let's say. But you can write just at least 2 or 3 numbers after the decimals, just so that we're not rounding too early. This wasn't a question that we had to actually solve, so it didn't say how to round. But let's say we want to round to the nearest hundredths. So I'm going to grab my calculator still. I'm still on the calculator, but this time I need to take the square root of this because we're trying to find b. I don't want b squared, so I square root both sides. And now I can write down my final answer for b, rounding it, after I type this in. So second square root gets, or the second x squared button gets us the square root. It's right, that x squared button right here on the left. Then you're just either copying down 134 point, a couple of numbers after the decimal, or there is this answer key button that makes it a little bit more accurate, but it's up to you if you want to do it that way or just typing in a few of the numbers. So we get 11.59. As long as you're, again, in that range, close to it, that should be fine. But what we just found is the missing side B. Okay, so we're done here. We found B. Now if we wanted to find the other angles, we could, but that's what I'm going to kind of jump down to the bottom, where we're going to try out that question at the very bottom where it says solve the triangle, and it's going to give us 3 sides only. So you're going to see by the end of today, hopefully, that law of cosines will work if you have this type of SAS scenario, I like to call it, where you see an angle and 2 sides surrounding it, and you're looking for the side across from that given angle that you have, the only one angle that you have. It has to be that side that you're looking for. Now, if you were looking for one of the other 2 angles, then instead we have to use a different equation, right? So this one worked because I was looking for lowercase b. All right, we're gonna move down to the very bottom now, and still let you see at the same time the law of cosines equations are right there. Okay, now we're gonna try to, there's a diagram of a triangle, and we're trying to figure out what it's asking me for. When it says the word solve, though, we did discover this a couple of days ago last week, where it just meant find the missing everything else, the angles and the sides. Well, we know 3 sides. That's good news for us. We just have to find the missing angles now. So if I label my triangle, A, lowercase a is 11.6, B is 13, and C is 18. I'm not writing the units there, but everything's in terms of feet, so my final answer, if I was to write something, would be in feet, but we are trying to find angles, so we're going to write degrees on all of our answers. And we are asked to round to the nearest hundredths. Okay, so here's where we have to decide where to start. There's not only one way to start, because if it's solving, we have to technically find everything. We need to find all 3 angles eventually, but you decide, do you want to find which angle first? So I'm just going to go alphabetically. So I'm going to go for finding measure of angle 1 first. Okay, so if I'm looking for the measure of angle measure of angle A, I'm going to just mark that so we have an idea of what to look at. And you go back up to your 3 equations to decide which one to use. You want the one that has a capital A in the equation. The only one that does that is that top one, because that's going to be my unknown. But what I should have is I should have numbers in for all these lowercase letters, A, B, and C, everywhere that they come up on this equation. Okay, so I'm going to start with, remember, A is 11.6, B is 13, C is 18, and remember, you don't have to memorize this, you're just copying it down one thing at a time. So to find measure of angle A, we're going to start with 11.6 squared, because that's A squared, equals, then I'm just following the next thing. It says B squared, so that's 13 squared. Then the next thing says C squared, that's 18 squared. Okay, so 13 squared and 18 squared. Then there's a minus sign and a 2. And again, I'm just following the order here. B, again, was 13. And C was 18. Okay, and then right after that, the word cosine. And we don't know angle A, so we're just going to leave that as a variable. So again, you can only have one variable. Notice everything else has a number put in for it, just A is the only variable. But what's tricky about this now is the angle is like on the right-hand side where there's all these other numbers. And so I can't just grab my calculator once and be done, where I just typed everything in like the last one, where I can just square root and be done. I have to instead kind of do this in a little bit of pieces. So I can figure out what 11.6 squared is, first of all, because I want to figure out that left-hand side of the equation. And try your best not to round too early. Like I want to call this, I want to just write the whole answer there, 134.56. Now, of course, if it's too many numbers, pick like 3 or 4 to write out a few numbers after the decimal. Now, you don't have to do each thing individually. I think it's easy enough if you kind of group these together to get an answer. 13 squared plus 18 squared is 493. So that you don't have to find every little thing typed into the calculator one at a time. I can just do a little bit at a time. Okay, and then there's this minus 2 times 13 times 18. All of that can get typed into the calculator all at once as well. There is a minus sign on the 2, so like either put a negative or just don't forget that negative sign. 13 and 18. Okay, and then we get negative 468, so like a minus 468. Now cosine A is attached, like it's being multiplied to that negative 468. So a common mistake here is to try to subtract these two numbers. Can't do that because this is just a number and this is 468 cosine A. It's like an X almost attached to this. So when I solve this, I have to still get this cosine A all by itself. So this is where I'm going to start by subtracting 493 on both sides so that I can get my getting closer and closer to getting A by itself, cosine A by itself. So again, just use your calculator. 134.56 minus 493. And this comes out to negative 357.44. You will get negative numbers sometimes as you do these. And then it's got to equal, notice how it's still negative on the right-hand side. It's negative 468 cosine of A, capital A. And I'm almost done. I just want cosine A all by itself, so I'm going to have to divide both sides by negative 468. If I do it to one side, have to the other, and then I grab my calculator to see what I'm left with. Cosine A is all I have left over on the right-hand side now. So negative 357.44 divided by negative 468. Okay, and that's where we get this decimal answer, and this is where you don't want to round too early. Please don't round that to like 0.8. Keep a few numbers after the decimal, because if you round too early, your final answer will be not as accurate. So I'm going to write about 0.76, and actually this answer, depending on if you used, wait, I'm sorry, I did 358, 1 second, 3. I'm sorry, it looks like I made a mistake up here back when I was subtracting. I subtracted 135.56 instead. So I'm going to fix that real quick. It should be 134.56 minus that 493. So this is going to be negative 358.44. Sorry about that. And then when I go to divide negative 358.44 by negative 468, now you should get negative, or I'm sorry, it's positive 0.765, and now this time you can either round up to 9 or keep more numbers after the decimal, but we do need to keep track of all of that. All right, so we have about 4 numbers after the decimal. We are almost done, but we learned just last week that when we want to find angles, and it's in this form, cosine, you have to take cosine inverse of both sides, at like -1 that we can write in instead, right? So if I do it to one side, I have to do it to the other. I'm going to grab my calculator now and type in second cosine to get that cosine inverse to show up, and then either type in those 4 numbers, or you can even press second and the negative sign to get the answer key button. I'll show you what the 2 answers look like because they're close, but just to show you that rounding definitely makes a difference for your final answer. You can see how they're similar they're both 40.01, but then it starts to get a little different. But again, it's okay to round, just try not to round too early, where I don't want to round to like cosine inverse of 0.8, because that would have been a not very accurate answer. But my final answer here now for measure of angle A is 40.01, because they wanted me to round to the nearest hundredths, and so that would be that final answer. Okay, now that was a lot of work just to do one angle, and I know that's not always easy. Even on the test, you won't have a bunch of these because they do take a little bit of time. Now, technically, we are supposed to find all the remaining angles that are left, but at this point, to find, let's say, angle B, you have a choice that you could use this same idea of law of cosines, right? Because now you still would kind of do the same setup of what we did to find angle A, or you have the option to check, could law of sines actually work? Because we saw that and we know that how to do that one. I honestly find it a little bit shorter sometimes, but it's up to you. If you think law of sines will work here, remember you just need an angle and a side, and since we just found this measure of angle A is 40.01, I can write that in here. I have the angle and the side across from it, so I could do law of sines. So it's up to you which way you want to practice. If you want to do another law of cosines, just to kind of wrap up soon, I'm going to go ahead and just do law of sines here, and it'll be good practice because you saw this last on Friday. So remember, you start with sine of the angle, so in our case 40.01, that's angle A, so I have to divide it by the side opposite, which is side A, 11.6. And then set it equal to sine of the next angle I'm looking for, which is angle B, or if I wanted to do C, it's up to you, whichever one you wanted. But remember, go opposite that angle. So if this is angle B, I need to go opposite angle B, which is 13. Lowercase b is 13. Okay, and then at this point, we cross multiply and solve until you find your missing angle B. So this would turn into 13 sine, or actually I'll write the other side first. 11.6 sine of angle B is equal to 13 sine of 40.01. And then remember, you're trying to get sine B alone, so we'll divide both sides by 11.6. So you get sine of angle B equals, and again, here's where you're going to get a decimal answer, and you do want to pick a few numbers after the decimal here so that you're not rounding too early. So just type it in exactly like you see it, 13 sine 40.01. And if you didn't want to type in 40.01 and you want to keep the previous answer, that's fine too. It's okay though if you want to write 40.01 and then divide it by 11.6. And we get, again, a decimal answer. Keep a few numbers after. I like about 4 numbers. So 0.7205, and now we're ready to take the sine inverse of it, of both the left side, and type it in to the right side. So sine inverse, second sine, 0.7205, or you can use the previous answer, and we can round this to the measure of angle B is approximately 46 point, that's going to round up to 1. Because the 9 can't stay 09, and I know that's only tenths, so if you want to write 0 after you can, or just leave it 46.1. But that would be the measure of angle B. Of course, if you rounded slightly different, we might get slightly different answers for our final answers. We are almost done. I know that was a lot, and so measure of angle C is the easiest to find, because now that we've found 2 out of 3, you know that in a triangle, the triangle sum theorem says add up all the angles and they have to add up to 180. So you can just take 180 minus angle A, which was 40.01, minus angle B, which is 46.10. And when you subtract that in your calculator, you should get approximately 93.89. And again, it's okay if you're rounding slightly different than I am. They all are not going to be necessarily the exact same answer. So as long as you're close, you should be good. So the measure of angle C is 93.89 degrees. Okay, so we have all 3 of those angles. that we had to find. That's how you solve a triangle. You're not going to have to do that every time, only if it says to solve. And so you just know that this was hopefully just for practice sake. We did law of cosines twice, we did law of sines once, and then this last part was just finding that missing angle. So if you feel like you need more practice of this, if you go to the next page, there are 2 more law of cosines type problems that you can try out for more practice. That's 8.10 practice. And then you also have your homework, the back page of that sheet that you got on Friday with 8.10 practice. So try your best with those. I will go over them tomorrow.